Hello, how are you doing? Hi everyone, hope you're doing good. So today we are going to work on the lab. Sorry, I fell behind on grading again. I'm gonna try to get stuff done tomorrow. Let's see. I'll update your grade. So let's check out lab for this week. Then I'll share screen. Okay, we'll start in a minute or so. Let me see if I have the code. All right, so let me post the code for exercise 1. Okay, so as you look through the lab, I'll go ahead and explain the code in a little bit, but I just added the code here for you so it's easier for you to see. Okay, let me edit something real quick. All right, we'll go ahead and get started. Okay. For this week, we are doing lab 5, which is we are gonna solve the problem using LC-3. And to start, the code is here. You need to download this document so you can see your lab, and exercise 2 code is below that. Okay, so check back on the assignment and then you should be able to see. So what we're doing today is we are going to write an LC3 program it's going to ask the user to input the integer 1 value 0 to 6. And each time that the user entered the value, it's going to display on console the day of the week. So for example, if I entered the number 0, it's going to show Sunday. If I enter 1, it's going to show Monday, and so on. So if I enter 5, it's going to show Friday. And to prompt for the input, we're going to ask the user to enter the number by using the string, please enter number. And the output, instead of the value, we're going to convert that to string and display the day of the week. So we are going to use dot strings today, like what we've been in the second week. And it is null terminated. So depending on the number of characters. So when you're looking at Saturday like this, right, you have 1, 2, 3, 4, 5, 6, 7, 8 character. So because it's null terminated, that's going to be 9 because there is an extra, right, null termination in the back. Now, what we want is we are going to make sure that we are displaying the entire string, and I'll talk a little bit about alignment because some of you are going to have issue with that today. And when we're doing this, how we work with string is that in LC-3, 1 character per memory location is stored, and each location is 16-bit wide. So similarly, what you see in C or C++, when you initialize anything with char, right, it allocate that space. Now remember that we're on low level, so we have to think about the word as 16 bits, and each of the characters is going to take up the word size. And so the least significant bit is going to hold the ASCII value of the character. And because it's null terminated, it can be conveniently defined with the dot strings directive, right? Remember how we did that at the beginning? So we're going to come back to that today. And when you do that, when you're using strings with the Z, it automatically append the null character in the string because it's null terminated. And so when you're looking at this, right, if we're looking at the word Sunday or the string Sunday, we have 1, 2, 3, 4, 5, 6 characters for the word Sunday. And we are going to add the null termination at the end. So that's going to be 7. So we're going to use the dot strings, and we want to make sure that we specify. Very important today when you do this lab, you got to make sure that your days are aligned with the character. So when you're looking at the code, okay, that I uploaded right here, you notice that my S, my M, my T, all of these needs to be aligned correctly, right? That means that Sunday have 6 character, the Wednesday have the most character, so you have to give yourself the number of space that's going to align with the other days that have more characters. So make sure that we are aligning these correctly. That means that it needs to be straight. Otherwise, it's going to cut off the days with the longer or more characters. So if I don't align things correctly, what will happen is for the Wednesday, it's going to cut off part of the word. Okay. So Sunday, because it's 6 character, and if you count Wednesday, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 characters. So I got to give 3 blank space after the Sunday, after Monday, and then 2 blank space after Tuesday. Thursday, I got 1 blank space after Thursday. Friday, I got 3 blank space, and so on, because you got to make sure that it's going to fit for the days that have the most character, which is Wednesday. Okay. So we want to make sure that we align it. The reason why is if you don't, it's going to push everything in other section of the memory and it's not going to display the entire string. Okay, so keep that in mind. We got to make sure that we align everything appropriately, and we got to give the number of space, the blank space that's left, that's equivalent to the longest string that we define. All right, any question? Okay, so let's talk about the code. As we know, we are going to output, right? We're going to output the day of the week based on the number input from the user. And in order to output string on screen, or on the console, we need to put in the beginning address of the string to register 0. So we can load effective address. We got to make sure that we load that and define it in strings. And we talked about LEA this week and also before. To output, instead of using out, we can then call puts, and that is the pseudo instruction or the directive that's going to use trap hex 22, and it's going to be able to display. So when you're using put command, it's going to go through a trap system routine, and it's going to output the null terminated string using the address of the first character. So when you're defining the dot strings, basically the register 0 is going to have, or when you load effective address, the register 0 is going to have the address of the first character of your string, and that's how it's able to find what your string is defined as, right? So here, it talks about how the address of that is loaded to your register 0. That's how it's able to read your string that's defined. Now, for the user input side, we're going to use getC instead of in. And getC allows the user to put only one character, right, after they see the prompt, one character. And in using getC, we're going to use the system the trap routine hex 20. So it's only going to read a single input, a single character input from the keyboard. Once that key is strike, it's going to send a signal. And in the code itself, right, we are going to take the value of the input and we got to convert it for ASCII. And that value is going to come in from register 0. So when you're using getC, it's going to refer to register 0 for the input value, and we manually have to convert it. So that way it would see the equivalence. And then for the 8th most significant bit for the register 0, then it's going to clear. Now, if you have one input, that's going to be one getC, right? And we're going to talk about the second example where we need to have multiple inputs and how that's going to be for the months. So it will not have any of the echo read character. So in the example here, they show you that we're going to use getC. It's going to place the ASCII value of the input to register 0. Then on the next line, when you receive the value from getC, you need to copy it. Okay, so here on the next line, I'm going to take that value, I'm going to add it with hex 0 to copy it to register 3, right? So we're going to duplicate that value and put it on register 3. Then we're going to subtract 48 because now we're working with character. Remember when we did the hex conversion to a number, right? Like we add and subtract 30. But you saw that there's limitation in that. So what happened is we need to subtract 48 offset, okay, to get the actual value. So here is where you are going to add. And in LC-3, it does allow you to use negative value this way. We can do the 2's complement, but using 16, that will be a lot. So we can add negative 16, add negative 16, add negative 16. So these 3 lines serve as a way for us to convert the input value to hexadecimal equivalents, okay, or numerical equivalents of the input. Because when it comes in as human text, we need to convert it to computer numerical value, so that way we can make sure that it's range or its scale for the ASCII value. Okay, so this is the ASCII conversion. And so we need to make sure that we subtract 48. Why can't I subtract 48 with 1 line? Remember that we talked about immediate value. When you're adding a negative value or you're adding a positive value, whatever it is, the immediate number, the immediate value needs to fit in 5 bits. And so 48 is going to be larger than 5 bits, and you can plug it into your program calculator and see. Then we have to break it up into 3 lines. Each line, that way, each of the value that we add is going to fit into the 5 bits. Okay, so 5 bits here, 5 bits here, and 5 bits here for the negative 16, negative 16, negative 16. So if we add negative 16 3 times, we are going to get negative 48. And that's going to allow us to convert for ASCII. And so here I talk about immediate operand for the add is 5 bits. And this is a way that we can use the negative or the sign value. And negative 16 is the most that we can fit in that 5 bits. So that's why we do it 3 times to make it 48. Okay. So when the user pressed the key 5, because we are applying the conversion, so the ASCII value of the 5 is 53. 53 is going to be placed onto register 0. Then we're going to subtract 48 from 53. We're going to get 5 as a result. Okay, so we want to convert this so the computer can the microprocessor can understand what that value really means, because between the text and the actual value, there is a 48 in difference, 48 in decimal difference. So we want to take 48, subtract it, so that way it can understand that it is a 5 that was entered. Before we output, in this case, we're not outputting a number, we're just outputting a string. So before we output, in the case in the future that you're doing your project, when you're outputting a number, you got to add it back, so that way it can convert it to text. So between text and the numerical value that the computer sees, right, is a 48 decimal. Okay. And when you're defining the days of the week, as I mentioned before, when you're defining the days, you got to pay attention to Wednesday, because Wednesday has the most character in its string. The length of it is 9. Okay. And it is null terminated, so it occupies 10 locations. And so we are going to use that as a template for all the others. So if they have less characters, we are going to use the blank space, right? If I have 6 characters for Sunday, I'm going to add 3 blank space to fit it into the 9. Or, I'm sorry, 4 blank space to make sure that it's null terminated. So 3 blank space and a null termination. So 3 blank space with a null, that's going to fit with the 9 for the Wednesday. So if you have less characters on each of the other days, you got to make sure that you use your space bar to space it after the last character to make sure that it fits 9 total character in a string. Each string, okay? So the blank space here counts. All right. And then, so here we're going to look at the numerical code for the day. And as you're looking at the days, it's as we increase, so it's going to be the index plus days times 10. So the address of the day is the address of the label days, okay, as we define the days here. And the beginning address of the Sunday that's going to be the first one. So think of this as the array of a group of strings. It's going to refer to each of these addresses, and Sunday is going to be the first one. And as it points to that string, it's going to look at the S, the first character. That's how it's going to be able to find Sunday. And each of the character takes up 16 bits. So you have actually an array of addresses that would make up the string or the word Sunday and Monday and Tuesday and so on, right? So it would cut up a section of the memory and 16-bit for each of the character in your string. So what we're seeing is that our algorithm is basically going to be sequential, conditional, and iterative procedures. All right. So let me go through the code with you, and you can take a look at the image from your Canvas page. Hold on 1 second. Let me load it. All right. So as I posted on the assignment page, I'm just going to use this instead of putting it out to Word. You can also expand your image or zoom in if you like when you look at the assignment page. So we have some comment at the beginning. We state what our program is about. And in this one, just like all the others, we're going to start with the origination address. So you would have .org hex 3000. And we are going to implement the prompt using LEA, but I also have a label called restart. Okay. So this is a way that we can implement a while prompt. If you're writing a program and you keep wanting to ask the user to enter a number, right? You can just loop it back. So you would have a while loop, and then you just, have a cout in C++ or C. So very similar to that, I'm actually going to keep prompting the user. So I would have a restart label here. And I'm going to load the effective address to register 0. It is a dedicated register for input-output on console. So I'm going to do LEA R0, prompt. And prompt is a label that I later define a string to ask the user to enter a number. So as you look at the comment, it tells you that it's going to prompt on console, right? We load the effective address to that. So when it does this, it's going to go to this label, and it's going to put the address of my strings that's defined here. Please enter number 0 to 6 onto register 0, and that's how it's able to read it. Then after that, I'm going to have a put because I wanted to display that onto my console. Okay. So we're going to do a put to display the string. And then the next process that we need is after we prompt the user, now we got to record what they enter. So we are going to use a getC. And it's going to listen for the keyboard signal for one character. So it's going to read character input. So if the user strike a 0, right, it's going to then tell the user that it is Sunday. So get C here records the input, 1 character. Then as I have the input that goes into register 0, just like the example that you see in the lab document, we're going to copy it to register 3. Okay, we're going to copy it to register 3 and we're going to compute from register 3. So I would take register 0 that has the input value. I add it with 0. Anything added with 0 is itself. And I put it on to register 3. Then next, I got to do ASCII conversion. So I would take register 3, which now has my input value, and I would add -16 decimal. That's how you use the negative number in LC3. Now, other ASM language, it might not allow you to do this. So you have to do the 2's complement. Okay, so just to avoid so many 2's complement for the 3 steps, in LC3, we can use negative value. And the most we can fit is 16 on a 5-bit. So we are going to add -16 decimal to register 3, which has our input, and put it back on register 3. And we would continue to do that the second time and the third time because we need to subtract 48 or add -48 for ASCII conversion. So I put the note here that register 3 would have an offset of 16, right? -16, we subtracted, so it moved down 16, then 32, then 48, 3 steps. And then now what I want is I want to do input validation. And as you write your regular C++, Java, Python program, you want to also control how the user enter their number. So we want to make sure that the input is going to be in a range, right? 0 to 6. So in order to check it, right, you would either apply if-else statement, or, in other languages like in Python, we would want to, check it using to see if it's a digit or is it a character. So in this case, we're going to check it to make sure that it is 0 to 6. So in order to do that, we need to subtract 6, right? Anytime that you branch, you got to make sure that it checks for the value, because microprocessor, it's only going to care about what number that is before it applies the logic. So we are going to add -6 to register 3, which has our converted input. And we're going to place it to register 4. Now, when we subtract 6, so if the user entered the number 7, 7 subtract 6, you're going to have a positive value. So that's going to give you an error, right? So anything above 6, what we're checking here is we are going to generate an error string. So this is why we're going to branch for positive. And how does it know what value it is? It's going to check in the destination register from the previous line, which is register 4. It's going to say, oh, the input value, if it subtracts 6 and it comes out to be a positive, then it's going to send it to the error label where we're going to prompt the user that is invalid input. Okay, any question? All right. So this section allows us to include, right, what we see as input mechanism in our program. So this part of the algorithm is for input. So we need to input, we need to prompt, get the input, copy it, convert it, validate it, right? And then now we're going to move on to the output. Then after this, what we need to do is we are going to load effective address to register 0 for days. And you saw this in the lab document. Okay. And the days are later defined in strings, like Sunday through Saturday. So we want to later define that, and that's part of the data section. That's how it's going to be able to retrieve it, and we can add it, or we can put it. So then what we're going to do is we are going to set up 0 branching. Okay. So in this part, what we want is we want to start our loop at 0. So just like what I talked about last time, when you have a loop, if it's a for loop, you want to have a start, a stop, and an update, right? In C, C++, and other languages. So in this case, what we want to do is we want to initialize 0 here. We're going to take 0 and we're going to add it to register 3 and put it back onto register 3. And it's going to use this to check for the branch. Okay. So when we branch, what we're going to do is we're going to branch. If it's 0, it's going to display. And on the display, we're going to do that. We're going to do a put, right? We're going to show on console. Then what we're going to do is we are going to loop it up to 10. So this is your start, right? And this is your stop right here. So after you branch for 0 and send it to display, the program will pick up right here. So this section for the loop, we are going to go ahead and add 10 to register 0. The 10 here represents Wednesday with termination, null termination. Because there are 10 characters, right, including the null termination, 9 plus a null, that's 10. So I want it to loop, because why am I looping? I need to access from the start of the first character, which is, it could be S or M or T or W. And each of the character takes up one memory allocation. So I need to go through and I need to go S and then U and then N and then D and then A and Y and then possibly blank after, right? For the Wednesday, I'm going to access all the characters through the loop. So basically, we're looping through to access each of the character in our string by doing it 10 times, starting with a 0. And as we go through, we have to subtract 1. If you think about looping, right, you count down as you go. Or in this case, why am I subtracting 1 is because if you're thinking about the memory location, it's going to move down 1 each time. So as I'm going through the first character, for example, that's an S, subtract 1, it's going to go to U, subtract 1, it's going to go to N, and that's how it's going to be able to move each time forward into the next loop. Okay. So after we add 10 to register 0 and put it on register 0, we got to go through, and this is how we update, is we are going to do a decrement. We're going to add a -1 to register 3 and store it onto register 3. And we're going to send it back to loop, which is it's going to check for the 0 again. So when it reaches 0, it's going to display because it has all the character. And so we're going to keep looping until we reach 0. And we're going to start from 10. It's going to subtract 9. 1, that's 9, 8, 7, 6, 5, 4, and so on until it gets to the 0. So we're going to keep sending it back to the loop, and it's going to do that until it has nothing to show, right? So any question regarding the loop on why we're looping and how we update through the loop? Okay, no questions. So for the next part, what we're going to do is because we're using the display label in the loops, we have to define it. So for the display, automatically we should do a put, right? And puts allow you to put one character, or I'm sorry, the string. So it show on screen for the string. And then for the LEA, we are going to load effective address to register 0 for LF. And LF hold the days of the strings. Okay, so basically it's another location. And what you see here is we're going to fill it with A because A represent 10 and 10 has 10 characters for Wednesday, the longest string that we use. Okay. All right, so after we have ls, we're gonna do the put, show on screen, and then we're gonna send it back to restart. Send it back to the beginning for the loop to prompt again. So reloop back to prompt. Now we previously had branch for the error. This is for input validation. We have to define it. So for the error label, we're going to load effective address 0 for ERMS. This is what I use for error message. And so after that, we're going to do a put. So in the case if they input a value that's larger than 6, we're going to output invalid input. So for the put, we're going to define invalid input here for ERMS. And then after that, we halt. So for prompt, we're going to do a dot strings. And if you want, I can tap this out like this. That's better looking actually. So we're going to do a dot strings, and we want to put in enter the number 0 to 6, or please enter the number 0 to 6. And then for the days, as I mentioned earlier, in case you missed it, for your strings, make sure that your quotation mark, right? And then in between here, you have to have the characters that's going to fit in to the 9 space for the character with the null termination. It needs to be straight with Wednesday. Okay. So if you're off by 1, it's going to cut off a character. I'm going to tell you that. So when you run your code and you test your days, if your days are cut off, check your data definition. Okay. So look at your days on how you type it. This one is a little tricky. It's short, but it's tricky. All right. So the strings, I define Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then for the ERMS, for the input validation, I just put invalid input. And you can do more in this, like you can say, invalid input, re-enter 0 to 6 only, or some kind of message, but we can say just invalid input. My LF, I have hex 000A because A represent 10 in decimal. This is in hex. Hex A is 10 in decimal. And 10 decimal Y is because we have 10 characters for Wednesday, 9 with the null. Okay. So it needs to make sure that it allocates. So basically we're using the fill value, right, for LF, which is here. And then after that, we can end the program. So we would have the .n for our code. So once you have everything entered, you assemble. Make sure you save it as a .asm. And you can test this on the online simulator that we've been using, right? Copy and paste your code on there. Load it to the assembler, assemble it. And then if you're using Windows PC like me, you would save it as a .asm and then click ASM button, or you can use translate and then assemble. After that, you can open up your simulator and you're going to load the program. And then this one uses console, so you're gonna go ahead and run it, and it's not ending, right? So here it waits for my keyboard input on my console. So let's say if I put a 2, it's gonna tell me Tuesday. If I put a 4, it tells me a Thursday. If I put a 7, it tells me invalid input and it exits. Okay, and then if you want to retest it again, you can reinitialize the machine, open this up, open up your assemble program, right? And then run. 0, right? We can do a 0 Sunday, we can do a 5, 2, and then you want to test an invalid input. Let's say I put a 9 and it exits. Okay. So our input validation works, our conversion work. And so like I said before, if your days is not showing all the character, check how you define your strings, make sure that it is aligned, and make sure that when everything fits to the number of characters for Wednesday, which is 9 with no termination. Any question? Yeah.
So how do we identify which day it is? What piece of code identifies it?
What day it is? Right here.
Okay.
So basically when you do the subtraction right here, it's for input validation, but this is going to load. This is to display. This is for the output of the days. Now, the order of how your string is going to be the days. So this is the first address, that's going to be Sunday. The second address, that's going to be Monday. So if you mix them up, whatever that you define here, that's what's going to display. So if I type a 0 and if I accidentally put like a Friday here, it's going to show Friday. It's not distinguishing the order based on the number. The number just point to the first, the second, the third address of the string. The first string, the second string, the third string, and so on. So the 0 is the first string. The 1 is the second string, and that's how it's able to tell. So as a programmer, I have to put in the order that's supposed to be. And the computer, it's only going to execute based on that order. So if I mess up and I put the Friday here, it's going to show Friday as a 0. Understand? It's just the order of how you put it into the memory.
Okay.
There's no mathematical algorithm in that. Good question. No one actually asked me that before. I just assumed that they know. So good. I'm glad you asked that, so I explain it. Other questions? All right, so with that, what you see is that we can take an input and we can use that input to point to the location of memory, right, by order to be able to display the days. After that, subsequently, we just got to make sure that we have the proper algorithm on how it would convert, how it would loop through and access all the characters that we have in our string. So in the case if you do a program that has a longer string, you can't just use the 10. It's not looping up to 10. It might loop for a higher number. So for example, if I'm doing something like month, where I would have more or less character, I would use the number of the character in how I define my months, which is exercise 2, to be able to loop from 0 to the last character for the month that has the most character in the string. Okay. And we would update our loop. So think about how you would do it on the higher level, and that's how you implement it on the low level. It's very much the same, right? Cin, convert, okay? Then start the loop for showing all the characters. So if you initialize your character in an array, you're going to have to loop through each of the character to show your character in that array. So that's what we did here. So string is an array of character. And then we do input validation. Any other questions? All right, so simple enough. I think for this program, right, you can test it with the required values here, 0, 4, 5, 6. And then I like you to test it with a higher value, like a 9 or an 8 or a 7, to see if your input validation works. And I put this here. How do you debug the day of the week program? I think from my prior experience with other groups of students, the biggest challenge that they have in this program is defining the strings, because everything else is there. It's pretty straightforward. They don't align things properly. They don't have the appropriate number of space after. And so what you can do, if you run into a problem that's not showing your entire string, you need to make adjustment from the prior definition, or like if my Monday is not showing correctly, you need to make adjustment from the Sunday, and also make sure that things are aligned for the Monday. Because if you have more space on the Sunday, it's going to cut off the Monday and so on. Because remember that what it does is it goes to the address. It doesn't know, like, it doesn't know your entire string technically. It's just the address of the first character, and that's how it's able to display your string. So if that's off, it's going to push everything else off. Okay, that's the biggest challenge for this particular program. Okay, and then if everything works out for you, then you might not have any challenges, but make sure that you note that. Yep, that's right. Wednesday have the most. So if you have a space after Wednesday, it's gonna break everything. It's gonna cut off the other strings or the subsequent string. That happens a lot. It's common. So I just want to point that out. So hopefully you don't spend a lot of time fiddle with it, because it's just a very minute thing that you need to fix sometimes. And you got to be patient with it. So make the adjustment. And like I said, blank space count, right? Because it's really using the address of the character, the first character, to really look at it. So yeah. All right, so answer some question. And it kind of teaches you on how to really debug it.
A question with the offset 48, is that for the because where the character starts on the ASCII table? That's where
Yes,
0 starts.
we're using decimal.
Okay.
We're using decimal instead of hex, this one.
Okay.
So if you look at the ASCII table, its offset is 48. Difference is 48. Yeah, let me pull that up since you asked. So when we go back to our online, right? If you look on the left here, that's the decimal value, it's 48. Like in the past, we used hex 30. Okay. And we only need like 0 to 6 for this one, so it's not too complicated where we don't need additional stuff. So yeah, we're using decimal on this one, so you have 48. In the past, we use hex, so it's the second column is 30. Okay. All right. Other questions? Okay, so this is a harder one, the second one. I want you to put forth the best attempt. Okay. And if it's not coming out like how you want it, right, and you try your best, I want you to troubleshoot it. But I did put the code up that was done by one of my former students. He's at UCLA now. He was the first one in 2020, I believe, or 2021, late 2020. He solved it, right? So, and then I've had other programs, and I will share that with you after this week. That was submitted. That was somewhat pretty decent. But I want you to think about how what you learn in this exercise that's going to help you in your project, because you are going to require to have ASCII conversion and input and output on your project in LC-3. So if you understand how to fix it or implement it now, it's going to be a lot easier down the line. Okay. So in the part 2, exercise 2, we are going to write a similar program. What I want you to do is think about what you did in the first one and apply it in the second one, but you have to tweak it a little bit, right? And when you see the program that's the code that I posted there, it is very lengthy, but see if you can make it a little bit more efficient. Think about how you would use it, and then kind of like a template, but improve it. That's the whole point. Now, the harder part on this is that your input use 2 characters, okay? Because we're working with months, so you are going to have the integer range 0 to 11. 0 is going to be your January, and 11 is going to be your December. We're going to work with dates a lot in this class. Next one, we're going to do some equation, right? We're going to use a formula for dates. So we're going to talk about that down the line. And when the user input a value, it could be 1 or 2 digits. You can require them to use 2 digits always, right? Sometimes that is better. Like 00 for January, 11 for December. It's going to output the appropriate month. So similar to the first program, we're going to prompt them to enter a number. And once they have input their value, it's going to convert it to the month of the year. Okay. And be able to output the month of the year. And we need to implement sequential, conditional, and iterative, like loops, branching, and then just, picking up with the PC and be able to continue the program top to bottom. Should say this up. All right. And so what I want you to do is, after you have your program, you are going to provide screen captures of your tested input. You cannot use the same value as the last one, because remember that you got to take a look at the number of characters for the longest month. Okay. And also you have to think about, how these are the years, the month of the year versus the day of the week, right? Your conversion. Okay. In assembly, simply converting 1 digit is really easy, right? Converting 2 digits, you have to do double the work, because you have to think about how this digit, so interpretation from the developers is really how you solve the problem is going to be different. Do you treat them as digits or do you treat them as actual value? Like this is a 10, this is an 11, right? This is the next. So when we're looking at mathematical value from a human perspective, a lot of the times we think about, okay, 1 through 9 and then 10 is the next range that we would see, 10 to 19 and so on. So as you go larger in your integers range, you're actually, you're not just increasing the digit to the left, but you're treating the value in 10 increments, right? Like this is because it's a decimal, we want to indicate that this is a multiple of 10 in each of the range as we move to the larger set. And so this is the conversation that I also have down the line when you're working with like larger value. Do we treat things as 1, 10, 100, 1000, or do we treat it as 3 digits that is actually just displaying on the console? So your interpretation of that as developer is really essential, because when you're treating as digit, you simply bringing it in as digits, just, you know, the left character, the next character, and the following character, and so on. But when you're treating as a mathematical value, like a 10, a 100, or 1000, what you have to do is you have to think about how you multiply that as a range of 10. Okay, so that's why when you see the solutions in a lot of these programs, sometimes developer just interpret it a little bit different. Some people treat it as mathematical value, and some people, they just treat it as digit, left to right or right to left. And in low level, you can do that. You can just say, oh, it's just a character, and I'm just going to push that character to fit it onto the console a certain way where the user would see it as, you know, 100, 1000, 300, and so on. Okay, so think about that when you solve these type of problems. Right, any questions regarding our exercise 2? I think I put the code on there for you. Let me come back to here. So I have a document. This is a little bit longer because, and I had to piece it into like 3 images. So I found that, or 4 images, I found that it is better to do it on a document where you can download and kind of look at your thing versus put 3, 4 pictures on here, because it just makes the page very long and it's very tedious. So you can download this and take a look, but I'll run through it real quick just to explain it to you. And of course, you don't have to do it this way. I actually have another page that I will share with you. Let me see. I think I didn't turn it on yet. So once I have your solution, I'll take a look at it. I used to make this as an extra credit. Yeah, I do have it. So I've had students that turn it in as solutions, and you know, some are better than others. Some work really well and some had a little bit of improvement needs, but I will share that with you down the line. Okay, like next week. All right, let's take a look at the example code. So at least, you know, but I want you to attempt on your own, looking at this problem and the first exercise and see how you would write it, right? Not using Kevin's code, and see if you can come out with a better program. Okay, and that's the challenge. All right, do your best. So let's take a look at let me see if I have it built. Hold on 1 second. Sorry, let me save my first program because I edited a little bit. I had put things in another folder, so let me go get it. Interesting. Ugh, I cannot find the ones that I had built, but okay, so let's just go with this one. Let me zoom in real quick. 1 second. Maybe 200. Okay, so let's go through the code real quick. So like I said before, everybody looks at the problem and solve it slightly differently. It's really depending on how you see things and what you see as needed to be solved. So just keep that in mind when you take a look at this, because sometimes you can say, oh, well, what if I do it like this? Or what if I add the negative value right away, then I don't have to do the 2's complement. So that's something that you can take a look and improve. All right, so looking at exercise 2, we are going to, similar to the first one, we see that there's a prompt here, right? We are going to ask the user to input the value. So start and then load effective address to 0. And we're going to do a prompt very similar to what we see in the first one. And then we're going to output that on console. We're going to do a puts for the string. And in this one, off the bat, it has requirement in input validation, right? Some of you, when you write your C program or C++ program, you take the input value and you input validate right away at that variable, right? So this is the approach on this one. So for the first input validation for the first character is that we are going to obtain a character for the input from the user. And then just like the last one, we are going to copy it. So register 4, it's going to copy to register 0, I'm sorry, 0, copy it to register 4 by adding a 0. And then here, there's a clear in register 5. So we clear register 5 on the next line, we and register 5 with a 0, and then place it back onto register 0. And then, so for here, this is going to be loading -57 to register 5 for the 2's complement. So this is why you see with the 2's complement here. So all of this add up to be -57. And then, so if you look at what Kevin's doing here is that he is converting and input validate at the same time. Okay, just like how earlier you saw that we subtract 48. But if you're looking at the 48 offset and what he's trying to do is, if you take 48, right, let me open up my calculator so you can see. If we have decimal 48, we take 57 and we subtract 48, the offset on this is 9. Okay, so what does this 9 represent in this program? It is the 9 that what you see in how the month is going to be translated, because we have 0 through 9, and then after that it's going to be 1 0, which is a 10, 11, 1 1. So what he's doing is at 0 through 9, he's looking at that range, and that's a single input. Okay. And then after that, it is a double input, which is a 10 and an 11. So the 9 represents the maximum value from 0 to 9, just like how you look at the 6 earlier, right? And then that's built into the offset itself, right? And then, so here is what you see is that we are going to take the input and we're going to subtract 57, okay? So it's doing input validation here. So once it's subtracted, and if it's branching positive, so if it's positive, then it's going to send it to error. So if they input anything outside of that scope, it's going to be invalid input. And then clear register 5. And here is the ASCII conversion also. So instead of subtracting the 48, like -16, -16, like what I showed you earlier, on this one, simply it's adding 48 and then find the 2's complement. So you see, like from a different developer, right, you would see that if you do the 2's complement, it's going to look like this. So we are going to have it, or this is going to subtract 48, and then it's going to input validate. Okay, so we are going to subtract. If it's negative, then we're going to branch to 0. And so if the input has ASCII value that's lower than 0, right, like a negative value, then it's going to be invalid input. I personally feel when I look at this over and over again, I think that, there are better ways, but this is a really good attempt in how we want to control what is converted and what is input. And then copy register 5 to register 1. This is the actual numeric value after the ASCII conversion, like what we've seen in the last example or last exercise. It's going to load the num to register 0, and you can scroll down and take a look at what num means. We'll get there soon. And so where we left off, let me see. Yeah. For register 3 here is going to store the copy of register 5, which is the converted value from ASCII. And then we're going to set up for 0 branching. So we're going to add register 3 with 0. It is itself. And if it's 0, right, it's going to branch 0. Okay. So for the loop, it's going to start here. So we are going to, this is used to display the double digits. Okay. So loop label, if it's 0, go to display. Now it's going to do increment for 2 because it's 2 character, right? 1 0 1 11, so 1 1. So 11 character for the numbers including the no termination. Okay. And then so we're going to offset by 1 to update by the decrement because we're moving it down for the loop. And then we're going to branch back to 0. So it's going to continue to loop until it reaches 0 by subtracting 1. And once it gets there, then it's going to go to the next part. Okay. So as we say, the display M1 here, we're going to do a put. So it's going to, when it gets 0, it's going to display the string. So the first number on the console. Any question? All right.
I have a question.
Sure.
I don't understand in both this example and your example where he's doing add 15 into register 5. What's that about?
So if you take a look at what the numerical value is on the ASCII table, so when I put in a 9, right? If we're taking a look at the decimal 9, the decimal 9 added with 48 is going to be 57. On a single digit, if you're looking at decimal value 0 to 9, 9 is the maximum value that we treat as a single digit, right? After 9 is 10, it's double digit. Understand? So
Yeah, I guess I'm just not understanding like why he chose to use a decimal 15 and then do it 3 times.
you don't have to. You can do 16 like what I did in the last one.
Okay.
Because he, in this, and like I said before, when you're looking at the program on how the developer write, yeah, I can do this as 3 lines, subtract 16 to get a 48 for ASCII conversion versus I am versus doing in this with the 2 complement where it is 6 lines. So everybody sees it a little differently. So for him, making it into a positive value and then do the 2's complement makes sense, and that's what he wrote. Is it wrong? No. Is it longer? Yes. Okay. So the way that he did this is he's looking at how you go from a single digit to a double digit value. If you're looking at the decimal range, it's 0 to 9, and that's the maximum of the range. But when you go to the next one, so how do you input validate that, right? You input validate that by checking against 9. Okay. Then when you move to 10 and 11, it becomes a 2 digit. So you have to handle the second digit. So this is why he's doing the subtracting to input validate the ASCII converted value against 9. Okay. And in the last program, I used -16 because I chose to, skip the extra. Yeah, I can do add 16, but adding 16, so you have to look at the limit of the 5 bits on what you can add each line. You cannot just add 48 on one line. It exceeds the 5-bit size value. Okay. So you have to break it up into 3 or 4 or 5 steps.
Okay, that makes sense. Thank you.
Yeah, you're welcome. Yeah, so the value that you're adding, the immediate value has to fit into the 5 bits. If it exceeds the 5 bits, you have overflow and it will throw an error because it only handles 5 bits for this value on each of the instruction line. Okay. And so therefore we have to make it into multiple steps. And in Kevin's case, he could do a little bit higher value and then, as a negative value for LC3, and then not do the 2's complement. But I have no problem with people having 2's complement. That's fine, because if that's how you see it, that's how you see it. Okay. All right. So now when you approach this problem, if you're looking at exercise 2 and you're solving it, your way, like I said before, think about how you're treating double digits, right? Like, 0 through 11. And that's how you're going to be able to do that. And on the low level, we normally, if you handle 1 digit at a time, you're going to have to manually like convert it and then validate it. So what Kevin did was he took the 0 and validate, right? Like the low range to the 9. So it has to fit within that range, and then he validate the 10 and the 11, the double digits after that. So, and that's why it's a little lengthy. Okay. So here, that's for the first digit. This is for the second digit. Okay, so what you see is here is the second digit. So when the user put in 1111, right, it's gonna validate. But if I put in like 13, it's gonna check the input validation for the second character, which is what we're looking at now, and then be able to say that it's an invalid input. Okay, so it's just a lengthier way. So here we're gonna do a get C for the second number, right? And then we're gonna copy it to register 4, very similar to what you've seen in the last one. Clear register 5. We're gonna load negatives 57. So this is the 2 complement of 57 because 9 is the range. So he's treating the first digit 0 through 9 and the second digit 0 through 9, and that's what we're validating, right? In my opinion, I would do this a little bit different. Instead of the first digit, I would just do 0 and 1, which is what he had in the last few lines, and then skip the rest because you really don't have to check it against 9. It's only going to go from 0 to 1, and then do it there, so you can skip this part. Okay, and then we are going to take the input, subtract 57 for input validation. This is to check against the maximum value, which is 9. I think the second digit is okay to do that. And then when it's positive, right, it's going to send it to check enter. So branch positive input had ASCII value that is higher than 9. So it would send the user to re-enter the value again. Okay. So this can be cleaned up a little bit because when you're looking at the keyboard, input value is not going to be larger than 9, but I think just for numerical purposes, that's what's done here. So of course we can improve this. Then we're going to clear register 5, right? Do the conversion for the actual input. And then what we're going to have is we are going to take the input, subtract 57, and he's checking here for the negative value. So if the ASCII value is lower than 0, then have them re-enter. Okay. So a little thorough. Is it realistically absolutely required? You know, in my opinion, the user has to type 2 keys to actually put in a negative. So might not be required there. And then copy register 5 value to register 2. And that's the ASCII conversion value is going to be the same duplicate from register 5 to register 2. And then we're going to load num to register 0. Okay. Then we're going to copy register 5 again to register 3. So now we're going to work toward the output part. So next is we are going to check. So set up 0 branching. We're going to initialize the loop at 0. This is our base of our loop. It's going to branch to display the second M2, right? And then we are going to do the double digits here. So 11 character for numbers including null terminated. And we're going to increase or decrease, right? Subtract 1 until it gets to 0. And we're going to keep branching until it does so. So this is how you can use a branch with a branch 0. And this is similar to my program that you see in exercise 1. And then we're going to do an output because we have that label here. So if it reaches 0, it's going to display. Okay. And then after that, we're going to branch it back to loop 1. Okay. Now, when you're looking at the month, September, I believe, is the longest string, right? It has 9 characters, kind of like Wednesday. Plus the null termination, it is 10. So this is where we are going to load the hex A for the new line. So we're going to clear register 5. We're going to add hex A into register 5. And then we're going to set up the 2 complement. So it's going to subtract. And then we are going to take register 5. I'm going to add it to register 4 and put it on register 5. So your input is going to subtract register 5. And if you look back in register 5, right, we have to convert it back to your ASCII. Okay. And so for the negative positive branch, this is for also error input. If they input other characters like text, then that's not 0 through 9, then we're going to branch it to 0 to error. So negative, positive. Then copy register 1 to register 2, since we're keeping the ones, right? So because there's double digit and it's going to be 1 0 and 1 1. So we're going to copy it and then we are going to clear register 1. So once it's copied, we know that it's in register 2. Earlier we had sent it to loop 1, so we're going to check the value, and here you see that Kevin actually treated as a double digit as tens. Okay, so like I said before, some programmer, they treat it as just digits, left, right, and so on. Other programmers, they treat it as numerical value, as tens. Okay, so here what you see is that it's going to check for the tens place, right? To the left, the 1 represents the tens value. So we are going to add that to register copy, or I'm sorry, add register 1 with 0 and put it back on register 1 for the loop. Then it's going to look here to branch for 0. So we're going to go to prep n for 0. If it's negative, we're going to send it to error. And we're going to add 10. This is the maximum value for our index. So as it loops, it's going to go all the way to the end of the array of your characters because September has 9. And so as we do that, we got to do, so here it's going to add 10 to register 2. And then we're going to not register 1. Okay. And then add 2 to register 1. So it's going to be negative register 2 plus 1. And then we're going to subtract 1 from it. So it's just going to keep looping until it gets to 0, where it's going to send it to prep m. And then we're going to add the new line, show on console, and clear register 0 for input validation. So it needs to be less than 12. And then we need to add 11 into hex B because we again need to loop for 11. There are 0 through 11 for the months. So this is what you set up for the loop. Okay, and as we do that, we would have the comparison. So we subtract at 1 point for 11. Then for the branch, it's going to go to register 0 here and look. So for negative 0, it's going to go to good in. And so if the entered number is 0 to 11, it's going to go to good input. And so this is for when we combine the input validation, we need to have it to the label. And then for the error, if it's invalid input, we're going to send it to error num. So invalid number string, display that on screen. We're going to also load effective address for LF. This is going to be for new line and display. Okay. And then go back to the prompt at the beginning, which is start. For good in, it's going to load the months to register 0, starting with the first month, which is January. We're going to clear register 3. Here, we're going to set up the branching for the display. This is similar to what you've seen in mine. So when it branches 0, it's going to go to display. And register 0, because we're treating for the 10 character for the months, including no termination. So when you're looking at September, that's 10, right? And then, so it's going to loop through the character to display each of the character that represent the month name. And we're going to send it back to loop 2 until it has nothing, right? So it's going to keep going. So that way it display all your characters. And so for display, we're going to continue to put that. So when you see it on console, you see it as a string, but ultimately it's each character at a time. So we saw that here. And then we're going to load effective address to register 0 with LF again. This is going to hold the months for the string, display on screen, and we're going to branch it to start. For the error, we're going to have a new line, and then we're going to display the error for input validation, not an integer, not a valid index enter. Try it again. So what you have is you have additional string definition here as where you would have how it checks 0 through 9. Like earlier, that's what you saw with the 57, right? And then so if I enter a 0, it's going to display a 0, right? And then it's going to check against whether it's 0 through 9. If I enter a 1, 1, it's going to check the tens digit and the single digit, where it's going to be displaying December. Okay. So there was extra effort in the input validation in this program. I give him a lot of props for that. I think, you know, something on the C level that's going to be a little bit more complex on the assembly level. So he was thinking about how, you know, it can be treated as a tens, a hundreds, or whatever digit. And so once you go through and you understand how it's put together, or you write your own program, you will have a better understanding of what the computer actually sees as, you know, numerical values compared to what the human sees. Okay. So just like the last one, if you test this program and and if you run into issues, check your strings definition, make sure it's aligned and it has appropriate character, especially with the months. So September is the longest, right? So making sure that everything matches up with September, no space after the R in September, but the other ones have less character. Make sure we have the appropriate blank space after, and align them up so that way, you know, it's easy to kind of detect if it's off. All right. Any question? Okay, so what I suggest is when you're looking at this, right, if you see number 2 a little bit different, you don't have to do it exactly like this. This is just an example for you to look at on how we would solve the problem, right? You can implement some of the practice from the prior example or this example in your program. But like I said, a lot of this work toward your project. So in your project, I'm going to ask you to have some form of input-output ASCII conversion. And so we have to understand how to do this so you can attempt your project. And once you do that, it's going to, you know, all the other ones are going to be really easy because you understand how to solve the problem step by step. And assembly makes you do that, right? In order to make a loop, I have to branch, I have to set all of these things up before and then I have to decrease. So you really have to understand about the loop structure or how I can exit a while loop and so on. Right, questions? Okay, So with that said, let me see. So for the exercise for lab 2, right, do your best, whether you want to use the program that's provided there, or I encourage you to make your own, and then you can test it and test your input validation. Okay, and then tell me what kind of challenges you have and how you fix some of the problems. Even if your program doesn't work to your liking, that's fine. I will show you some example of some of the students that submitted their programs from before. Even though I felt like, sometimes it's displaying one character on each line because it's using getC, it's not the cleanest, but it worked. And then, they were able to work with it and be able to output something that's, that's achieving the objective, but it could be improved. So I'll share with you some of that on a page of the module. Okay, so any question? Okay, yeah.
The answer for the lab, question C, describe how you debug. What do you want us to put for that?
Well, what kind of debugging that you had gone through, right? Like if you have syntax problem, if you have alignment space problem, but if you don't have any kind of issues, you can say that I didn't have any problem with my program, right? But what I encourage you to do is to not just copy and paste the code. I mean, type out the code like what is given to you on the screenshot, right? But what I encourage you to do with number 2 is to write your own program based on what you understood so far as how to write a loop, how to be able to use strings, how to be able to do ASCII conversion, and then have your own program. And then tell me how you go about fixing it and improving it and what kind of problem you have. Okay. Other questions? Now, if you turn in the program exactly like what I seen on I put on the screenshot on the lab assignment, like Kevin's program, my program, I expect that you understand what that program is. Okay, so if we're following the example, right? So as we do that, when you use your simulator, I encourage you to use the options that's up here, right? Or on the simulator online, like how you step over and trying to take a look at and understand what each line of the code does and why are the labels there, what is it used for. Okay, so that way it is more effective in understanding how the code works and what's given to you, because sometimes you would get into a job place and they would ask you to take someone else's program, debug it, right, or improve it, or sometimes you co-write the program, so other programmer will hand you their part and then either you add on to it or you modify it. So team collaboration is very common. So we want to really understand everything, and so that way, even if they write a little bit different than us, making sure that we are able to see it and then improve it or fix it. Okay. And a lot of open source stuff is there. Sometimes we take it and we modify it and we improve it and then we reshare it. So any other questions or concern?
Yeah, on Kevin's program, if you input, how would you input 10? Would it be like, would you be able to do 2 digits?
It's 1 digit at a time. Yeah. He
So-
later on improved. You're gonna see later on we're gonna have a better program. So
it's possible to, is it possible to do 2 digits?
2 digits not using getC.
Okay. Okay.
So what I'm telling you is, this is what I tell all my students is you have to think, you have to see what the computer is receiving, right? If I'm using getC, for example, it's gonna take one character and put it on register 0. Right? That's 1 digit. Then what I can do is I can take a second character. You can fit it all in one, it's fine. What if I take, if I need a second input, if I'm using a same get C, what I need to do is I need to take the first value that was in register 0, copy it right away. Right? And then and so if I do get C and get C, copy, and then get C, and then copy, I actually have 2 input in 2 registers, and then use those registers for conversion. You can have double digit, but you just need to, so in this case, we're going to prompt the user input the first digit, input the second digit, right? But you can have it, if you're using get C, you have to move. And even if you use in, you're going to have to move it, right? You got to take it, move it to another register, because it's entering the processor is going to see it from register 0. So you don't want it to be override by the second input. So if you think about how you would be able to record 2 input, you take, move, right? Ask for or wait for the second input, move, and then use the register that's copied to do the conversion. That's how you do it. Okay, any other questions? Okay, so yeah, for your project, you're going to have multiple inputs. So think about how you would handle that. Okay. All right. I think that wraps up the lab. Let me stop recording.